All right. We have an organization called Praxis, which is a student organization that deals with the economics and Mises's human action and that kind of thing. Anyway, it's actually a very popular club on campus. Anyway, I just wanted to let you know Adam Wade is the leader of it, president of it, or whatever. And there's going to be a meeting on Thursday at 7 in Lane 125, which is next door. So it's the first meeting of the semester, so if you want to just show up and find out what Praxis is about, you could, you know what, just put that on your calendar. So again, it's Thursday at 7 o'clock in Lane 125, which is next door, and they'll be talking about what events they're going to be doing. They bring in speakers and do things like that. All right. Also, does anybody want one of these, student planner? The added value of this seems to be, oh, you do, great. Okay, can you run that back to, okay. I thought the added value was near zero, but it's evidently above zero, so allow you to use that. Okay, good. All right, I'm going to take roll here today. Joel, Austin, Caroline, Paul Brophy, Andrew, Emma Burback, Brennan Bush, Christopher Butters, Leo, Ian Calvert, Elizabeth Dickinson, Claire, Audrey Guess, Benjamin Hansen, Daniel Harmon, Patton Harmon, Peter Harrigan, Claire Hensel, Maggie, is it Ronich?
Here.
What is it?
Ronich.
Okay. All right. Joshua Hypes, Justin Johnson, Jack Ketchum, Meredith Cottom, Thomas McGinnis, Celia Moran, Sabrina, it's Nardone, okay, Gabriel Powell, Benjamin Raffin, Laura Rain, okay, Jack Robinson, Caleb Sampson, Mark Sherman, Edward Skis, Andrew Verbrugi, took the thing here, Maggie Wackenhut, and Dana Weidinger, and Jonathan Welker. All right. Okay. So last time we were taking a look at the idea that you do things as long as the added benefit is bigger than the added cost, right? And we assume that added benefits go down as you get more of something, right? The additional benefit of the next unit of something, it adds to your total benefit. Probably it may be negative, but most of the time it'll add to your total benefit, but it won't add as much as the one before it. So if we were to look at the idea of added cost, we also said that we assume you have increasing marginal costs in that the added cost goes up as you produce more of the unit or you have to make more of the unit. And again, we'll talk more about this when we do supply curves about why that might be the case, but that's our assumption, right? We started out, this is what our assumptions are. So if we were to, again, draw a picture of that, Again, every picture tells a story. We just told you some story here. Did somebody ask me was it in this class that they asked me about what the other songs on that album, 1971 album was? Okay, well, if you listen, Maggie May is probably the big other. How many have heard the song Maggie May? Okay. Really. We really need to do better at rock and roll history. But, okay, so if what we did is we looked at in dollars terms here, and we had units here, we assume that the total benefit curve looks like that, right? And we assume that the total cost curve looks like that, right? That is, the slope of the total benefit curve is getting flatter as we get more of it, and the slope of the total cost curve is getting steeper as we do more of it. And what are you trying to do? You're trying to maximize the difference, right? That's the net benefit, right? That's the total benefit minus total cost. We could call that net benefit. And notice that as long as the slope of this thing is steeper than the slope of the total cost curve, that difference is getting wider, right? And when does it start getting smaller? When the slope of the total benefit curve is less than the slope of the total cost curve, then it's getting smaller, and that's just the story that we told. And so what's going to happen? Where those slopes are equal, right? Where the slope of the total benefit curve is equal to the slope of the total cost curve, that's where you maximize the net benefit. That's where you maximize the difference. And that's what we were saying, is that the added benefit is going to be, as long as the added benefit is bigger than the added cost, or as long as the marginal benefit is bigger than the marginal cost, you'll keep doing something. You'll stop when the marginal benefit equals the marginal cost, because extra units, the marginal cost is going to be bigger than that marginal benefit. Now, if you had any calculus, what can you do? What is the slope of if I have a continuous function where I've got benefit in terms of q, and I've got another continuous function with costs in terms of q, if you've had any calculus, what are you going to do? You're going to take the derivatives, right? You're going to set the derivatives equal to 0. In fact, why is that? It's because the net benefit is equal to total benefit minus total cost. And if I want to maximize net benefit, just from a calculus point of view, if I want to maximize net benefit, what I'm going to do? I'm going to take the first derivative and set it equal to 0. But the derivative of the sums is the sum of the derivatives. And so what does that tell you? I'm going to take the first derivative of total benefit, and I'm going to minus the first derivative of total cost and set that thing equal to 0. But when you do that, what's going to happen? I'm going to have the first derivative of the total benefit, which is marginal benefit, and it's going to have marginal benefit equals marginal cost at the point where the net benefit is equal to 0. So if you've had, don't worry about it if you haven't had calculus, but if you've had calculus, there's another way of looking at it. I've got a function which is total benefit minus total cost. So if I'm going to set that thing, maximize that thing, I'm going to take the first derivative, set it equals 0, and just the just the algebra of that is going to have you where the marginal benefit equals marginal cost. All right. So that leads us to demand. And again, the reason that we have done this marginal analysis is that the demand curve is going to be equal to the marginal benefit curve, and the supply curve is going to be equal to the marginal cost curve. So that's why we've gone through the analysis about this marginal analysis. So what is demand? All right. So what we're going to do demand curve. We're going to do supply curve. We're going to set them equal to one another, and that's the equilibrium. right? And it'll turn out that 9 million people woke up in New York City today, and there was exactly the right amount of Starbucks coffee again, even though there's COVID. There's exactly the right amount of toilet paper and everything else. How did that happen? Well, when we learn about demand and supply and equilibrium, that's why that happens. All right, so let's start out with demand. And demand is the relationship between price and how much people are willing and able to buy. People are willing and able. So if I'm looking at your individual demand curve, I'm saying, okay, I'm looking at your individual demand for Cheerios, okay? What does the demand curve say? The demand curve is going to say, how much are you willing and able to buy at various prices? And what do and notice that the think about what we're talking about here is that for you, your marginal cost is equal to the price, right? When you go to Market House and you go to buy Cheerios at Market House, it'll tell you Cheerios, $2.95. The first box is going to cost you $2.95. For you, the second box is going to cost you $2.95, and the third box is going to cost you $2.95, and so on. So if I were to say, how many boxes will you buy at $2.95, what are you going to do? Your marginal cost is equal to price, so at any price, what are you going to do? You're going to buy the amount where marginal benefit is equal to the price, so that if I said, how many Cheerios will you buy at $3, you're going to say, okay, let's say this is $3. And so that's the price, and I put quantity down here. Let's say you're going to say, okay, at $3, I'm going to buy 5 boxes. That tells me that at $3, that last box of Cheerios that you just bought gave you $5 in marginal benefit. Otherwise, you wouldn't have bought it, right? So what does that tell you? The fact that we assumed, right, diminishing marginal benefit, what does that do? It means that demand curve's got to be downward sloping, right? So if I draw your demand curve for something, how do I justify the fact that the demand curve is downward sloping? I justified it by saying you're going to do things as long you're trying to maximize your net benefit. You're going to do things as long as the added benefit to you is equal to the added cost. You're going to keep going until that happens. The added benefits go down as you get more of something. And what did that do? That then resulted in a picture that looked like that, right? Again, Rod Stewart's, that picture is telling a story. That story says, at lower prices, you will buy more, right? And how did we generate that? We generated that by assuming that you have diminishing marginal benefits. So in order to get you to buy that next box of Cheerios, what do I have to do? I have to lower my price. Notice that sometimes you'll go to a place and you're not 21 maybe, so, but suppose you go to a place, you might find that the first beer costs $4, right? But then the next beer costs $2.50, right? Sometimes you'll find places like that. First one, $4. Oh, or if you go to you go to buy some clothing at Powers Clothing or something in Jonesville, right? First suit, $150. Second suit, it's probably a cheap suit, but first suit, $150. Second suit, $75, right? You'll see that where they advertise, first one this amount, second one that amount. What are they trying to do? They're trying to price along there, right? They're getting you to pay more for the first one, and if I were to get you to buy two, I'd have to lower the price on both of them, right? But I might be able to get you to buy that first one and then get you to buy the second one by lowering the price, so I don't have to lower the price on both of them. So whenever you see some sort of advertisement where the first one costs this much and the second one is cheaper, then what's driving that is that the person that's selling to you is trying to sell the first one up here, then sell the next one down here, sell the next one down there, instead of having to, if I wanted you to buy 5, I'd have to make them all $3 in order to get you to buy 5. But if I could sell you the first one at $5 and then the second one at $4 and so on, then I could capture that, capture what's called, when you take Econ 202, I could capture what's called consumer surplus. That is, notice, just add a little bit here. Notice that what's the added value to you, right? If I were to look at total benefit, it's going to be what? The integral of this, right? It's going to be the area under this demand curve, because that's the marginal benefit curve, right? So all this amount is the total benefit to you, but you're only having to pay $3. So the cost used here and this part up there, the extra amounts, when you take Econ 202, you'll talk about it as consumer surplus. So they're just trying to capture that. But anyway, that describes why you have things like, again, when you get old enough, you'll be able to go into a bar, and what'll happen? Well, maybe if they don't have, are bars open? I guess, okay, so some bars are open. Anyway, notice that they have prices for pitchers, right? And the price for pitchers is lower than if you buy the individual amounts. So you go, hey, we might as well buy a pitcher, right? And we'll drink the fourth glass or whatever. So the reason that you get price for pitchers gets you to buy more than if they had to charge you for each individual one. So a pitcher is like sort of lowering the marginal lowering the price to you of that fourth beer. Like a pitcher might be, a pitcher of 4 might be the same price as buying 3 individual ones, right? So they're trying to so that's why you get things like that. Now, what affects what your demand curve looks like, right? So if I'm looking at your demand curve, it's at a certain location, right? It looks a certain way. So what affects demand? Okay. Let's think about what does the demand curve say? It says, how much are you willing to buy at various prices? And you're going to tell me, okay? But what gave you that? Could I do something that would change your answer? Or is there something that happens that changes your answer? Well, the first thing that's pretty obvious is your preferences or tastes, right? How many bottles of red wine I might buy depends on my preference for red wine. I don't particularly like wine. It'll be funny because you'll go out with somebody and they'll bring the wine out and they'll pour it, the waiter will pour it in there and they'll sniff it around and, smell it and do all this other stuff. I'm just going, what in the world are you doing, right? We're wasting our time here. But nonetheless, some people really like wine, right? They, the Broadbecks, Bill Broadbeck used to be chairman of the board here, and they live down, across the road here. They love wine. They know all sorts of stuff about wine. So your preferences will determine what your answer to that is, right? You could tell me, actually, this is an aside, there is one red wine that I like that I found, and it's Hillsdale Brewing Company down the road. It's got this bottle, this red wine that you can get for $11 a bottle, which is probably, is that at the high end of bottles of wine? Not really. Anyway, I found that I like that, but that's just an aside. So the preferences or your taste will determine where you are on that. Now, what if I wanted to increase your demand, right? In that I want to move that whole demand curve over to the right. What could I do to try to do that?
Lower prices.
Well, but if I lower the price, I'm moving along the curve, right? I'm not shifting the curve. So we want to be careful. In fact, it's important when you look at the old exams, for example, you'll see you want to distinguish between when you're moving the whole curve, saying I'm going to buy more or less at the same price, right? That's, are you going to buy more or less at the same price? So changing the price doesn't shift the curve, right? Doesn't move your demand curve. Changing the price moves you along it, but yes?
If I was a company, I could market in a way that would influence the preferences or taste.
Okay, and what would that be? She's picking up on the camera. She would do something that would try to change their tastes and preferences. And how might you do that?
Advertisement?
Yeah, advertise, right? That's what you, when you watch an advertisement, notice how few times when you watch an advertisement do they talk about what the price is. Sometimes they do. Arby's, we have the meats, right? And they'll tell you, okay, there's this. But most of the time when you watch an advertisement, they're telling you about how cool the product is, right? They're trying to influence to get you to buy more at the same price. So advertising will be, just as one example, that if I advertise, what am I trying to do? I'm trying to change people's preferences or tastes for the particular product. Yes?
I think you could also, just in trying to nail down preferences, to make sure, if you have a wider range of maybe products to offer, or depending on what or services, whatever, then you could draw in more people with different preferences without lowering the prices.
So she was saying that there might be a situation where you might have a wider range of product available, so people would come in. So, for example, if you had a restaurant, right, you might want to have more than one thing on the menu, right? So that way you might get people to come into your restaurant, and then they might buy something else, right? In fact, sometimes you'll see that where there'll be one of the things that you might do with a sale is to tell people that you're lowering the price, but then you get them to come into the store, right? So oftentimes sales are there to get you to come into the store, and then once you're in the store, you start looking around, and then you might buy something. All right. Second main thing that happens is income, right? How much are you willing and able to buy depends on what your income is. If your income is relatively low, then you might not be able to buy as much of anything as if your income is higher. So that if I change your income, I'm going to change that whole curve. How much are you willing to buy at the same price? Okay? And with more income, you might buy more at the same price. And we define, we have a definition of types of goods. One is called a normal good. And normal goods have the characteristic that as the income goes up, demand increases, right? The whole curve increases. You'll be able to buy more than you did before. So automobiles, right? If you're earning $10 an hour, then you're probably not going to go out and start buying Rolls Royces. If you're earning $1,000 an hour, then you might go out and buy Rolls Royces. In fact, my wife and I went out to Chicago to visit our younger son, and his girlfriend's parents have a boat, and it's in a very expensive place that you can put your boat out in Chicago. And so when I was walking from the boat launch to where our car was parked, I saw a Maserati, right? So I took a little picture of it, right? But why don't I have a Maserati, right? I would probably like to have a Maserati. There's a song about she drives a Maserati, faster than sound. But so I'd like to have a Maserati, but I ain't buying any Maseratis lately unless the college gives me a big raise. Okay. So normal goods are such that as your income rises, you buy more. But we also have what we call inferior goods. And inferior goods are the opposite. You buy less, right, at the same price, because we're shifting the curve. You buy less at the same price as your income goes up. So what might be an example of an inferior good? Yeah.
Bologna?
Bologna? Yeah, bologna, right? You buy, probably if you were making $600 an hour, you wouldn't be making bologna sandwich for lunch, right? Yeah. Ramen noodles. Okay, I happen to like ramen noodles, but ramen noodles, right? People buy more ramen noodles when their income is lower at the same price, but then their income is rising, they stop buying ramen noodles. Yes.
Hot dogs.
Hot dogs. Hot dogs might be as well. Although you could, if you get a chance to go to Coney's and Swirls, you can try their hot dogs. Yeah.
One-ply toilet paper.
What is it?
One-ply toilet paper.
I can't hear.
One-ply toilet paper.
Oh yeah, one-ply toilet paper. Yeah, okay, one-ply toilet paper. All right. So we can think of goods that as your income rises, you buy less of it. So those are called inferior goods, right? So when people's incomes change, notice that if you're looking at the economy as a whole and you're trying to look at what's going to happen to the people's demands for particular goods, as incomes are rising, what will happen? You'd say, hey, you know what? We don't buy, so we're not, that particular industry is probably going to shrink as people's incomes are going up. And as our incomes rise, things that are normal goods, we would say that industry is probably going to be rising. Third thing is, again, these are all, again, it's not rocket surgery here. The price of substitutes. Right? Two goods are substitutes if, when the price of one goes up, the demand, that is the whole demand, right? The demand for the other increases. So, if you're in Kroger's, you're in Market House, and you're shopping for, you're buying your groceries, and you look at the price of apples, and the price of apples just went up because there was some problem in the apple orchard industry or something like that, right? So the price of apples is increasing. What's going to happen? When you look at oranges, you're likely to buy more oranges at the same price as you did before because you moved up the demand for apples because the price of apples rose. So you moved up that demand curve, but then you shifted the demand curve for oranges to the right. You're going to buy more. So if the price of, you're in there shopping and, you start out and you're buying, you put the apples in your cart, and then you look over, it says, sale on oranges, right? Oranges half price today. What are you going to do? Put some of the apples back, right? You're going to move down that demand curve for oranges, and you're going to shift your demand. You're going to buy fewer apples than you otherwise would have at the same price. Now, there are some goods where it's the opposite of that. And so what affects that is the price of complements, right? And complements are going to be goods that you tend to use together. But again, technically, if the two goods are complements, what happens when the price of one goes up, the demand for the other goes down. That is, I'm moving up the demand curve for this good, and I'm shifting the demand curve for the other good. So again, obvious answer, hot dogs and hot dog buns. If you saw the price of hot dogs rising, right? If you have the price of hot dogs goes up, what are you going to do? You're going to move up, right? You're going to move up the demand curve for hot dogs. But what you're going to do is you're going to shift the demand for buns, hot dog buns, to the left, right? You're going to buy fewer hot dog buns at the same price as you did before. So complements tend to be goods that are used together. If there was something that happened to raise the price of ice cream, then demand for chocolate syrup would probably shift to the left. Or if the price of ice cream fell, then the demand for chocolate syrup would move to the right. You'd buy more chocolate syrup at the same price of chocolate syrup that you did before. Or ice cream cones, right? You'd buy more ice cream cones. If the price of ice cream were falling, you'd be moving down the demand curve for ice cream and shifting the demand curve for ice cream cones to the right. For individual demand curves then, we've got four major things, and this isn't all of them. These are the major things. Anytime that you say, I will buy more of it at the same price, or I will buy less of it at the same price because this happened, right? Then something happened to shift that demand curve around. But these are four things that are pretty obvious, right? If you have your preferences, the amount of income that you have, the price of substitutes, and the price of complements, those things will all clearly move your demand curve around. And then, if we look at that, so that's for individual demands. Now let's think, the market demand is the sum of the individual demand curves. Right? So if I'm looking at the market demand for ice cream, okay, we're going to have price and quantity here in three different spots. And person one here, let's say for ice cream at $3 per gallon, this person would buy 4 gallons. They're really in half gallons of ice cream. Ice cream come in half gallons? Yeah, ice cream tends to come in half gallons. So but let's say half gallons then. So if it's $3 for 4 half gallons, or that this person will buy 4 half gallons at $3, and at that same $3, this person would buy along their demand curve that looks like this. We'll call that D1 and D2. This person is going to buy 2 units. Then if there's only 2 people in the market, then the total demand is going to be the sum of person 1's demand curve plus person's 2. So at a price of $3, then you'd have 4 plus 2, or 6, would be how many you'd sell in the market. So if we have something that happens that increases the number of people in the market, then what do we expect to happen? That demand curve is going to be shifting out to the right. So let's think about 1978. China was not integrated into the world economy. So if you were a company and you couldn't sell product in China. If you were an American company, then you couldn't sell stuff in China. 1978, and we'll talk more about this later on, but 1978, China opens up what's called special enterprise zones. And what they did was they basically set up these provinces where you could start to have a market-based economy. And you could sell, American companies could sell into that area, right? And it began to move towards a market-based system. Now, what does that mean? Today, if you are BMW, right, you now have 1.3 billion people in your market that you didn't have before, right? So it will have shifted the market demand out to the right. So the more people that are in the market, then the market demand curve will shift to the right. So if you were an American company, what do you want? You want to have laws that allow it so that you can sell into other countries, right? You don't want a law that restricts your ability to sell things in Mexico, or restricts your ability to sell things in China, or sell things in India, or other places, right? So the market demand curve is going to be the sum of the individual demand curves. All right, so that leads us to a concept that we'll talk a bit about. We probably won't finish it today, but that leads us to a concept of elasticity. Elasticity of demand. And why do I want to know about elasticity of demand? And the reason is because notice that we said that the demand curve is downward sloping, right? Added benefit goes down as you get more of something, so it gets you to buy more. I got to lower the price, right? And that demand curve then is downward sloping. And if I'm looking at the market demand, and let's say I'm Dan Gilbert, and it's pre-COVID or post-COVID. Dan Gilbert owns the Cleveland Cavaliers, right? And he's got to decide what's the price that he's going to charge to watch the Cleveland Cavaliers, okay? So notice that because the demand curve's going down, if Dan Gilbert raises the price, quantity is going to go down. Now, Dan Gilbert is really trying to maximize the total revenue, because if you think about it, and again, this is a weird season, so forget this basketball season. Let's pretend it's last year's basketball season, or hopefully next year's basketball season, right? He's got all his costs are already there, right? He's paying his the players are all under contract, right? If he is buying the building, he's got the mortgage that he's got to pay. He's got the property taxes that he's got to pay. If he owns the building, he could have maybe rented it out to somewhere else. So, but all those things are fixed costs. We call fixed costs. Those are there whether he's got 10,000 people in the stands or 20,000 people in the stands. The cost of the next Cleveland Cavaliers game is going to be the same. So he's just worried about the total revenue. He's trying to maximize total revenue. So if he were to raise the price of tickets, he'd get more for every seat, but he'd sell fewer seats, right? As long as that demand curve is downward sloping. So P times Q, we don't know what happens to P times Q. If he lowers the price, right, he's going to get less for every seat, but he's going to sell more seats, okay? So we're not going to know what's happened to P times Q. If you think about it then, what does he have to know? He has to know which is going to change more, right? Is the price going to move more than the quantity, or is the quantity going to move more than the price? That's what he's got to know. So why do we want to know about the elasticity of demand of a good? We want to know the elasticity of demand because it's going to tell us what happens to total revenue when you change your price. What happens to total revenue, that is P times Q, when you change the price? If we're looking at this and price is going to change more than the quantity changes, then I ought to raise my price. When I'm looking at this, if price is going to change more than quantity changes, but if I lower my price, the quantity is going to go up more than, what did I just say? Did I say the price changes more? Anybody remember? Okay. So if price changed more, then the price would be falling more than the quantity went up. So I don't want to lower my price. So if the price is changing more than the quantity does, what do I want to do? I want to raise my price. Okay? But if you had the opposite, that is, quantity were changing more than price changed, then what I would want to do is I'd want to lower my price, right? Because the price is going to go down, but quantity is going to go up more. So the trick to knowing whether I want to raise my price or lower my price depends on what's changing more. So what economists do is they define a term, elasticity. And the definition of elasticity, right, if we define what elasticity is, again, economics has definitions of things just like physics has definition of things, right? Mass means a certain thing in physics. Elasticity means a certain thing in economics. It may be different than what you're used to using elasticity for. But there's a definition in economics, elasticity. And what is that? And we're going to use epsilon to be elasticity. All right? So epsilon, the elasticity is equal to what? It's equal to the percentage change in quantity divided by the percentage change in price. And we're going to take the absolute value. Why are we taking the absolute value? Because that's always going to be negative, right? As long as that thing's downward sloping, it's going to be negative. So we're going to ignore the minus sign out there. So we're really interested in, and why would I make that a fraction? I'd make that a fraction because if you set the Wayback Machine to 8th grade, and anybody know where that comes from?
Peabody and Sherman.
Yes, Peabody and Sherman. Very good. All right. So you got to watch Rocky and Bullwinkle. It's a great show. But anyway, Peabody has a machine called the Wayback Machine where you can walk in and you go backwards in time, right? So take the Wayback Machine and say, let's go back to 8th grade, and what do you learn? You probably learned fractions in 8th grade, or maybe before 8th grade, whatever. So when you learn fractions, what do you learn? What happens if the numerator is bigger than the denominator? Then that fraction is bigger than 1, right? If the numerator is less than the denominator, it's less than 1. So that's why economists define elasticity as a fraction, and it's the absolute value of the percentage change in quantity divided by the percentage change in price. What's that going to do? That's going to tell you is the percentage change in quantity bigger than, less than, or equal to the percentage change in price. If price goes up by 10% and quantity goes down by 10%, then P times Q is going to stay the same, right? If price goes up by 10% and quantity only goes down by 10%, or excuse me, by 6%, right? Then that fraction is going to be less than 1, right? If the percentage change in quantity is 12% and the percentage change in price is 4%, it's telling you that the percentage change in quantity is bigger than the percentage change in price, and so that's going to be bigger than 1. So the important thing here is this thing is elasticity bigger than, less than, or equal to 1, right? That is what elasticity is about, right? And why did I define it that way? So I could tell what's going to happen to P times Q. The way I tell what's going to happen to P times Q is I know whether P is moving faster than Q in a percentage terms, right? And notice that way you don't have to worry about units. If I talk about the price of oil in terms of gallons versus the price of oil in terms of liters, or the price of oil in terms of barrels, right? It doesn't matter because I'm taking a percentage change, right? So because if I didn't take percentage changes, I'd just look at the change in quantity, it would make a difference whether I was talking about what's the price in liters versus what's the price in gallons or quarts or whatever, right? So that's why I'm taking percentage changes. I'm getting rid of the units. So if the price goes up percentage-wise more than the quantity goes down percentage-wise, then what I ought to do is I ought to raise my price, okay? If the price is going down less than the quantity is going up, then I ought to lower my price if I'm just trying to maximize total revenue. And so that's why we talk about elasticity the way that we do, all right? So it's a number, okay? That's what it is. Don't start thinking that it's some other thing. Again, what Will Rogers, said, it ain't what you don't know that's the problem. It's what you know that ain't so that is the problem. So people oftentimes come in with a concept of elasticity that they've heard or before or whatever, and they've got that embedded in their brain. But that's when technically that's not what we're talking about, right? Force equals mass times acceleration. Force means a certain thing in physics, right? It's mass times acceleration. It's not how much the wrestler pushes the other wrestler, okay? So when we talk about elasticity, just keep focused that it's simply a number. Percentage change in quantity divided by the percentage change in price and the absolute value. All right, so for what we'll do on Friday, we're pretty much through elasticity, but we'll spend a little more time on that. And then we'll start to look at the supply curve, okay? So you should have finished the chapter on demand, and if you want to read ahead a little bit, you can look at the chapter on supply. All right? Okay. See you on Friday.